Section 3.5 covers rational functions, and in this video we're going to talk about finding the domain of a rational function. We have 4 examples here. In each case we are dealing with a rational function, which is simply a quotient of 2 polynomials. So the numerator is a polynomial and the denominator is a polynomial. And because of this, we can put any real number in a rational function just as we do with a polynomial. However, the denominator cannot equal 0. That is the only restriction that we have. So for these rational functions, the domain is all real numbers except those values of x which cause the denominator to equal 0. So let's look at these examples. This function, the denominator is x plus 5, and to find the domain, I'm going to set the denominator equal to 0 and solve for x. So I have, take away 5 from both sides, and I get x is equal to -5. So in this case, the domain is the set of all x such that x is not equal to -5. In this example, we have a denominator which is the product of 2 factors. So I set the denominator equal to 0. And because we have a product, we can apply the zero product rule, which says that if your product is equal to 0, then one of the factors must be 0. So either x plus 2 is equal to 0, in which case if we subtract 2 from both sides, we get x is equal to -2, or we have that x minus 5 is equal to 0, and adding 5 to both sides is going to give me x is equal to 5. So these are the 2 values that cause the denominator to equal 0. Therefore, the domain is going to be the set of all x such that x is not equal to -2 and x is not equal to 5. All right. In example 3, our denominator is x squared minus 4. So I'm going to set that equal to 0. And then I add 4 to both sides. And I get that x squared is equal to 4. Then I can take the square root of both sides to solve for x. And I get that x is equal to plus or minus 2. So the domain is going to be the set of all x such that x is not equal to 2 and x is not equal to -2. Finally, we set our denominator here in example 4 equal to 0. And notice that this is impossible. There's no solution to this equation. And the reason is because we are saying right here that x squared, now x squared could be 0 or positive. It cannot be negative. So you're taking a number that's greater than or equal to 0 and you're adding 3 to that and somehow you get 0. That's not going to work. The minimum is that if this is 0 and we add 3, we get 3. So there's no way that this could be true. So this has no solution. And so your domain, you're never going to have a 0 denominator. So your domain is the set of all x such that x is any real number. And by the way, these domains that I've listed here, they're all in set builder notation. I could put it in interval notation if I wanted to. And in that case, here I would have from -infinity to -5, and then joined with the interval from -5 to infinity. And this is interval notation. And here I can do the same thing I go from minus infinity to minus 2, from minus 2 to 2, and then from 2 to infinity. And here I would have minus infinity to minus 2, negative 2 to 5, and then 5 to infinity. And finally, we would have from minus infinity to infinity. So these are 4 examples where we are finding the domain of a rational function.